So now we got an Astable multivibrator made with an op amp. There's two op amps on this integrated circuit. I'm only using one of them. So the timing is set by the capacitor right there going to the minus input, the inverting input. We also have a resistor there coming from the output to charge and discharge the capacitor based on whether the output's high, red LED, or low, blue LED. So the voltages that it is charging and discharging to is set first off by these two equal value resistor voltage dividers right there. So that sets at half, but then we also have another 10K resistor here. They're all 10K coming from the output. So when the output's high, their voltage rises. That gives a higher voltage for the capacitor to charge to. When it reaches that point, then the output goes low. You get a lower voltage, less than half the supply voltage here, that the capacitor has to discharge to. So now here's the schematic diagram I drew for my Astable op amp here, and that's all connected, that's all connected, and that's all connected. I know a lot of people like dots, but in case, the output is going to determine the reference voltage right here. We got half the supply voltage, but a high output will raise that voltage, given a higher target for the capacitor to charge to from the output right there. These values set the timing. Once you get up to that voltage, then the output goes low. It lowers this voltage below halfway, and the capacitor has to discharge to less than half of the supply voltage. And it just keeps bouncing back and forth like that. And so while the output is high, of course the red LED lights up there. I actually used 220, but I got 470 written there. And didn't look at that closely. But in case, when the output's low, then of course the blue LED lights up.